Hello, Miss Howington here. So in this video we are going to talk about the atmosphere of Earth. To start with, the atmosphere is a thin layer of gases that surrounds the Earth. It's made up of lots of different layers. So let's talk about those layers. So the layer that we live in is called the troposphere, and it contains 75 to 80% of the mass of the entire atmosphere. Okay, so the air in the troposphere is composed of 78% nitrogen gas, or N2 gas, 21% oxygen, or O2 gas, and then the other 1% or so of the troposphere is made up of water vapor, argon, carbon dioxide, and some other trace gases. And those other gases, even though they're in such small amounts, they can play big roles in influencing the atmosphere. This is a layer that's super important to us because it's where we live, number one. It's where weather occurs and climate occurs. So all the processes in the troposphere pretty much influence life on Earth and help determine what kind of life can live where. The troposphere ranges from about 17 kilometers, or from sea level, which is 0 kilometers above Earth, to 17 kilometers above Earth, or, since we live in the good old US of A, that's 11 miles. As you go up in altitude, temperature decreases. That's because Earth is acting as a heat source, and so once the incoming radiation from the sun has been absorbed by the surface of the Earth, Earth then re-radiates some of that back up into the atmosphere. And so as you get farther away from the heat source, it gets cooler. So it's kind of like if you have a stove with the eye on and you put your hand right above the eye, it's really super hot. But as you move your hand up above that eye, it gets a lot cooler. So as we go up in altitude, we get to the tropopause, when there are layers, the layers that are in between the actual atmospheric layers, we call them pauses. So the tropopause is in between the troposphere and the stratosphere. So the stratosphere goes from about 17 to 48 kilometers, more or less, or, U.S. measurements, 11 to 30 miles. The stratosphere has much more ozone than the troposphere. The stratosphere actually contains the ozone layer. The ozone layer is about from 17 kilometers above sea level to 30 kilometers above sea level, or in U.S. measurements, 11 to 19 miles. And the stratospheric ozone layer is super important because it absorbs UV energy. And it doesn't make its way down to Earth, and that's pretty good because UV radiation can be pretty harmful to plants and animals on Earth. It can cause some DNA mutation. In the stratosphere, the temperature increases as altitude increases. Because the ozone layer is absorbing so much of that incoming solar radiation, it increases the temperature of the stratosphere as you go up in altitude. And then we go to the stratopause and then the mesosphere. In the mesosphere, that's about 50 to 80, it ranges from 50 kilometers and then it ends at about 80, or maybe a little bit more depending on the season, kilometers above sea level. And again, that's about 30 to 53 miles above sea level. And here in the mesosphere, the temperature decreases as altitude increases because in this layer of the atmosphere there's a greater radiative loss of heat than there is solar gain. This layer tends to get thinner in the summer and thicker in the cooler months. But the mesopause, which comes on top of the mesosphere, is known as the coldest part of Earth's atmosphere. So then we get to the thermosphere. This is about 85 kilometers above sea level to 500 kilometers above sea level, and again, depending on the season and the latitude, it varies in thickness, and in miles, that's 53 to 310 miles above sea level. And so here the temperature is increasing as altitude increases because this layer of the atmosphere is receiving a lot of solar energy. And so the higher up you go, the more solar energy you're receiving. And then you get to the exosphere, and then the exosphere leads out on into space. And so the thickness of these layers doesn't stay the same all the time. It varies with the seasons, and it varies with the latitude, so how far away you are from the equator. Or those are our basics, the structure and function of the atmosphere. So we'll talk about this more in class.